In this lesson, we're going to learn about mouse event with React 3 Fiber. It's actually more about pointer events. I chose to name this lesson mouse so that everybody understands, but it's more about pointer in general, because what we are going to do now, we work with other devices like, I don't know, like a phone. You will be able to click on the meshes, etc., and see the color changes and things like that. So yeah, let's go. About the setup, classic setup, we don't have much there. There is the sphere, the cube, a green floor. The cube is rotating. We have also some lights, the usual thing. I added Dray to the project so that we can have the orbit controls and rotate around. So we're going to start with kind of the classic event, which is the click. It's actually not the simplest event ever, but it's the most known event that usually we use like in native JavaScript. So let's go with this one to start with. Handling mouse event used to be tricky. Do you remember the lesson where we did that? It was the Raycaster lesson. We had to create a Raycaster instance. You know, it's that 3JS class. We had to cast the ray sometime on each frame, depending on what you want to do. Like if you want to test like when the mouse is moving and things like that. And then test the intersecting objects, meaning that we had to send those objects in an array. And it was a bit tricky, a bit tedious. Don't worry, things became much simpler with React 3 Fiber. You will see how in just like a few seconds. All we need to do is add an on-click attribute to an object in our scene. As an example, a mesh. We are going to do that on a mesh. And provide a function. Okay, let's try that. So in experience.js, we're going to create a separated function. So right here, you can put it inside the on-click attribute directly, but let's move it away so that it's easier to understand and we get a clean JSX. So we're going to provide a function, create a function. I'm going to use a classic arrow function. And in there, I'm going to put something like the event occurred. All right, for the name of the function, I put like a generic name, event handler. Usually, if that function will be triggered when we click on something, you name it something like, I don't know, if it's on the cube, it's cube click or cube click handler or cube click callback, something like that. Try to use variables names that make sense. We're going to use that name because we're going to test other events later in the lesson, not just click. We're going to test a bunch of events. Nice. So let's go. Next, we're going to try on the purple cube. So it's the second mesh, if I'm right. Yeah, that's this one here. And we are going to add, I'm going to put it at the end. The order of the attributes is not relevant. On click equal, and we're going to inject that function that we created right here. Event handler. Nothing too hard, and check that. I'm going to give it a reload just in case, and I click on the cube and it's working, and I will see you in the next lesson. Just kidding. As you can see, we have a bunch of things to see, but that's the general idea. See, with just one line of code, yes, I also created the function here, but I could have added the function right here. I can show you. Check that. With one line of code, I'm going to comment this one. You don't have to do it. I just want to show you. And I can click on it and it's working. Maybe it needs some refactoring. I can put, I don't know, like that, like that, like that, and it's working. Nice. I'll get back to the example with the separated function, but you get the idea. It's super simple. As a small exercise, let's push the thing a bit further. We're going to change the color of the box when we click on it, and we are going to generate a random color. Now would be a good opportunity to try it yourself. If you want to practice a little, pause the video and try to change the color of the cube when we click on it to a random color. And we're going to do it together. So let's go. First, we already have a reference to that cube because we are making that cube rotate. It's animated. So I've already created cube reference, meaning that in there we can access it, and then we're going to do cube, current, don't forget the current, material, color, set. All right. By doing that, we are just calling the set method on the color property, which is an instance of 3JS color inside the material, inside the cube. Nice. And in there, we can do the random color that we did in a previous lesson, you know, with the HSL, so hue, saturation, lightness. I'm going to go a bit fast on this one because that's not the topic of the lesson. So in there, we're going to put math random multiply by 360. I'm surprised that I forgot the deg here. Usually, I think you need to provide deg right here. 100% and something like 75%. All right, hue is there right here, which is a random from 0 to 360 degrees. Then the saturation is fully saturated, and the lightness is quite bright. Let's test what we get. And I did something wrong. Oh, that's weird. I think we need to remove the deg right here. Yeah, I don't know why, it's a bit weird. Anyway, it's working, as you can see. So remove the deg like I put it there. I should have followed the lesson. Good. I should have followed the lesson. So you can click on it and you get a different result. Maybe you got it. Congratulations. If you didn't get it, don't worry. It's fine. We need to practice. So by the way, yes, you can test on mobile. So as you can see, I don't know if the focus is working nicely. I can maybe move it there and check that. I'm just clicking on the cube and I get a different color every time I click on it. All right, I hope the focus is working. Seems like so. Nice. And I'm going to put back my phone there. So that was super easy. It's working. That's the click event. We just add an attribute and we can do whatever we want in that callback function. We get access to quite a lot of information when we listen to events like this. We're just going to check them because we don't really need those, but I wanted to show that to you in case you need those things. First, we need to retrieve it. It works kind of the events in native JavaScript. You retrieve a variable here, so an argument, and you can call it E or event or whatever you want, no spaces or something like that. I like to call it event. Then you can log it and check that. We get a bunch of information when we click on it. Like, check that. We get distance, page X, pressure, shift key, screen X, a lot of information. And actually, it's a mix of native JavaScript information and React 3 Fiber information. As an example, we get access to the distance. If I write event.distance like that, check in there, I get the distance. This is not native JavaScript, but we also get access to native JavaScript. Like if I put just X like this, we get the X. So it's that distance from here to here. If I click, I get the X and I can get the Y. I've put a bunch of examples. You can scroll down the lesson to get those. I would just read them to you so that you know that they exist in case you need those for your own project. Like the distance, so the distance is from the camera to the intersection point. The point in 3D absolute coordinates might be useful. I don't know if you want to create an explosion right here when the user clicks, you can. The UV on the geometry, if that geometry has a UV, maybe you want to draw something on the texture or some weird stuff like that. The object concerned by the click, this one is important, we're going to use it later. The event object, isn't it the same? Not exactly. In our case, yes, it's the same because the event that triggered the click is the same as the event we are listening the event on, but in different cases, it can be different. You can get a different object from the event object, and we're going to see that later. The X and the Y, which are to the, I think it's the style coordinates, meaning that they are inverted. I mean, the Y, I think it's going down like this, okay? It's 0 here and bigger there. The shift key, we can access the shift key, meaning that when we click, I can show you just this one. Check that, I'm going to comment the rest. You don't have to do that, I would just want to talk about those. I click, it's false. I click and I press shift, it's true. That can get handy. This is, I think, actually a native JavaScript. This can be handy in specific cases. I will give you some examples right after. And it works with the control key and the meta key. The meta key, I think, on Mac, it's the command. You know, we don't have the same control key as on PC. And well, anyway, those, when you need those, control and meta, test on both Macs and PC keyboards because it might be a bit different depending on the OS. So it's a mix of native and non-native, React Fiber events. The click event, quick note, the click event might sound like the simplest one, but it's more complex than what it seems. If I get back to the initial example, well, actually I can get rid of the logs. If you have the logs, you can remove them. The fact of clicking like that might sound super easy, but it's actually quite complex because, check that, if I click and move away and release, it didn't consider it as a click. If I click, then move inside and release, it didn't consider it as a click. A click is when we start on the object, we can move a little, I think, and release, and that's a click. And all of those are being handled by React Fiber. Just imagine what we would have to do if we were to do it on our own. I did it quite a lot, many times on projects, and it's a bit hard, really. So that's great. We can just listen to the event and let trust React Fiber to do what needs to be done. All right, we have a bunch of other events available. We're just going to see them. It's up to you if you want to do them with me or just follow the video. Again, it's just so that we know they exist. We're going to replace the onClick event right here. And the first one we're going to discover is kind of the right click, but it's not, the name is not right click. The name is context menu. Change it like this, or just watch on my screen. And how do we trigger this one? So the click isn't working anymore. I need to right click on it. Okay, I'm doing some right clicks. You can't see it because you only see my face, but I'm doing right clicks on my trackpad and it works with mouses. Why on context menu? Well, because it's not really a right click. It's the on context menu that can also be opened on mobile. Do you know how we open the context menu on mobile? It's by doing a long press. I think most mobiles are handling that the same way. When you long press, I don't know, like a link, it will act like you are doing a right click on desktop. So the name is context menu. Why context menu? Because context menu is opening that. You know, I'm doing it on VS Code because right now it won't work in there because there is the orbit control preventing the right click and the context menu from opening. But a context menu is this. When you right click somewhere, you get something like that. See, that's the context menu, and that's the context menu. Next, on double click, interesting. Let's do test it quickly. I'm clicking, nothing. I'm double clicking, it's working. That's all. Probably understood this one without testing. By the way, the delay between the first and second click is defined by the OS. That's an interesting feature. I'm quite sure this one is handling by the OS too. It's just like that. It's a OS setting. I mean the time between two clicks to be considered as a double click. Next, we have the on pointer up because a click is both the fact of clicking down and clicking up. So pointer down and pointer up, you get the idea. We can listen to them separately. If I test the on pointer down, check that. I'm clicking but not releasing, and now I'm releasing and it's working. So if you need to know when the user releases, you can do it like that. Next, on pointer down, it's exactly the same. So I replace by down, check that. I press, I didn't release the click, and it already triggered the event. I can do it again. I press and it triggered it when the cursor, I mean the button went down. Next, this one is quite interesting. On pointer over and on pointer event. I don't have to explain it to you, but I want to explain it to you, so I'm going to use the tablet. In native JavaScript, we have all of those that we are discovering right now, the double click, the pointer down, etc., are working in native JavaScript. And in native JavaScript, there is a difference between, I'm going to do a quick draw. Like if you have multiple objects like that, and another one like this, and I don't know, maybe a bigger one, those are divs, okay? I'm talking about native JavaScript. When you click on those, and those are inside a bigger object, all right, something like that, okay? On pointer over and on pointer enter, it's when the cursor or finger just went above the object, meaning that if you are moving something like, I don't know, like this, okay, that's the path of my cursor, cursor. It's going from there to there. I'm not talking about React3 Fiber right now. I'm talking about native JavaScript. If you're listening to the over event, you will get the event being triggered there. I'm talking about listening on the parent, the big rectangle that contains multiple divs. All right, imagine it's a huge divs with multiple divs. If you're listening to the pointer over, you will get one event being triggered here, 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 and here. All right. And if you listen, you do the same, it's the same situation, same movement of your cursor, but you are listening to the pointer enter, you will only get an event there. Okay? That's the difference between over and enter. The over will be triggered even when we are entering on the children of the element you are listening to, and we are listening to the big rectangle right here. In React3 Fiber, there is no difference between over and enter. All right, you don't care about that. So I could have just skipped this part and not explained this, but I know that a lot of JavaScript beginners don't understand the difference between over and enter, and this might result in more events being triggered than they really need. So I wanted to explain that quickly to you. On pointer out, did we try them? No, I forgot to try them, so we can try them. I'm going to put the code right here. So on pointer over, check that. I'm going to hover it. Okay, it's working. I move away, I go inside, I move away, I go inside. All right? It's when we go inside the object that this is being triggered. And if I tried with the on pointer enter without doing like a cube inside a mesh, a mesh inside a mesh, inside a groove, inside a mesh, just we are testing on a simple mesh. We're going to test more later with a more complex object. So if I try with on pointer enter, check that. It works exactly the same. There is no difference between over and enter in React3 Fiber. And it's the same thing when we want to know when the user leaves the object. We have the on pointer out and on pointer leave. You can put it there, on pointer out. I move on the object, nothing. I move away, the event is being triggered. And if I tried with a leave, I move on the object, I leave the object, it's being triggered, just the same. Next, we have on pointer move. This one is very interesting because it's being triggered on each frame. See that? So it depends on your frame rate. For me, it's 60 per second. But between frames, if the cursor moved, the event will be triggered. So if I don't move, even if the cube is moving, I'm not moving the mouse, the event is not being triggered. But when I move the mouse, it's being triggered on each frame. Nice. Next. This one is very interesting. The on pointer miss. If I use it on the cube, check that. I click on the cube, nothing is happening. I click away from the cube and now it's working, regardless of where I'm clicking. So it's a way to know when the user clicked outside of the cube. But this one also works on the canvas. Okay? It's when we released, by the way. We can listen to on pointer miss. So you're going to, if you do it with me, you can open the index.js because that's where we put the canvas. And I'm going to put it, yeah, right here. On pointer missed. I'm going to be lazy and put the function right here. Console.log. Oops. You missed. Like that. Okay, I'm just putting a console log inside the function inside the on pointer missed. And check that when I click away, it's being triggered. So it's a way to know that we are clicking away from stuff. And if I click on the cube, this one right here is not being triggered. So it will just check like you're listening to some events on some objects. If you click outside of those events that are being listened, it will trigger that one on the canvas. It's one way to kind of know when the user clicks somewhere else. Why not? It can be useful in some circumstances. By the way, what to use them for? That's a question I get sometimes when people are implementing some clicks and hover and things like that, and they just wonder about what to use them for, when to use this one or this one or this one. It actually depends on what you want to build. It should make sense. Like if you want you're creating a kitchen configurator and you want the user to be able to change, I don't know, like the color of the furniture, where if he clicks on the element, then you will open an interface. So you need to know when the user clicks on it. And it's not when the cursor went down, it's when the cursor went down and up on the same one, then that's a click. And if the user clicks outside of everything, you want to close those menus to choose the color and of the furniture. So you're going to add the on pointer mist on the canvas, and there you will say, okay, I'm going to close the menus, so that I will close the menus since the user clicked outside. He wants to do something else. It's kind of, for me, it makes sense. But I can give you a better example. Especially if you play games like, I don't know, Age of Empires, StarCraft, etc. So those are the RTS games. When you play, you know, you have some units, and you need to click them and ask them to attack that base, and then to wait there, or then you click another unit to add it to that group, and then you click somewhere else, so everything gets unselected. So when the player clicks on a unit, you want to select it. And when the user clicks, just click, okay, it's when the click event happen on another unit, then you unselect the first one and you select this one. When the user drags and drops, so right here, right now you're going to need to listen to maybe on pointer down, on pointer up. Maybe we'll do it in native JavaScript actually. You want to draw a rectangle, and when it releases, when the user do a pointer up, you're going to test on that rectangle that you just draw what units are inside that rectangle, and then you're going to select them. Then when the user do those, like the click or the rectangle, but the shift key, remember, there is a way to know in the events, I can show it again. In there, we can, from that object, we are able to know when the user is pressing the shift key. If the user is pressing the shift key, then you add those new units, those new selected units, to what units are already selected, okay? And when the user clicks, but there is no hit, so it clicks outside of any units, then you deselect every unit. This is, I mean, it's a long process. If you want to create a RTS game in Three.js with React Fiber, you're starting a great journey, a great adventure. So it's going to take a lot of time to handle all those clicks and stuff, even though it's going to be much easier with React Fiber. But it's just an example. It just makes sense. Try to do something that is actually making as much sense as possible for your users. All right, do some testing. If your users don't understand how to select the furniture, how to select the units, etc., maybe you did something wrong. So try to analyze how video games are working, how complex interfaces are working. Next, we are first going back to the click. So on click. Why? Because I want to talk about occluding. Check that. If I move the cube, watch my screen. If I move the cube like this, and I have the sphere between me and, I mean, the camera and the cube, and I click on the cube, it worked. All right? Makes sense. There is a ray being casted from the camera toward my cursor. It's going through the cube. There is an intersection, and it counts like a click. All right, that's the default behavior, and it makes sense. But what if we want to be able to occlude the cube so that we can't click on the cube if there is something blocking, occluding the raycaster? We can do that, don't worry. By default, the raycaster doesn't care about what's in front of the object being tested. Okay, that's what I just said. There is a way to occlude the cube. We're going to listen to the onClick event, but on the sphere too. All right, and we're going to tell that event, I mean in the callback event, to stop propagating the event. I can explain to you with some drawings. Yay, drawings. Let's say we have a cube, a spheres, and things like that. So let's say there is a sphere right here, then there is a cube right here. Okay, like that, like that, like that. And let's imagine there is something else. What can we create? We can create a cylinder, something like that, something like that. Okay, why not? That's a cylinder. That's not my best draw ever. And we are clicking on it, meaning that the camera is over here, like that. Tuk, 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 tuk. That's my camera. We are clicking, and there is a ray that will traverse everything. Okay. Regardless of the order we put the objects in the scene, React 3 Fiber, or maybe it's 3GS, I'm not sure, will order them by distance, meaning that React 3 Fiber will order them. So it's going to be this one, then this one, then this one. And this is super useful. If we are listening to click events on this one, on this one, and on this one, we are going to get all 3 events being triggered. But if one of them, we have this event that is being triggered, and this one asks to stop the propagation, so it says, no, we're going to stop there. This one won't happen, and this one won't happen. And we can stop the propagation wherever we want. We can stop it there. So these events, the one we listen on the sphere will be triggered. This one will be triggered. And if this one asks, no, stop the propagation, this one won't be triggered. Just like that. Super convenient, as always. And it's super easy. So meaning, if we want to listen to clicks on the cube, but we want to occlude the cube with the sphere, we just need to listen to the sphere. So I'm going to go back there. We are listening to the sphere. We are not doing anything in there, but listening to the sphere and stopping the propagation so that this one is not being triggered. Okay, it's just a way to occlude the clicks. Nice. So let's get back to the code like this. And let's move forward. So let's go. We need to listen to the click on the sphere. So it's the first mesh. And we're going to do, I'm going to be lazy and not create a function before. So on click equal, and I'm going to send a function like this. And in that function, we're going to call the stop propagation. And the stop propagation is available in the event I told you about. Okay, we had the event right here, and we are going to call it so event.stop propagation like this. It's a method that we need to stop. And since there is only one instruction, we can remove those like this. Now let's test the result. I'm going to click on the cube. Okay, so now the cube is visible. It's under the cursor. It's working. Okay, cool. And now I'll try to do it like this, and it's not working anymore. React 3 Fiber handled everything. We just asked the sphere to stop the propagation, and it will stop right here. Don't trigger those events because something was occluding. Okay, cool. Let's move forward and let's talk about the cursor. Yeah, that one is quite important if you're creating a 3D application and some objects are clickable. On desktop, one solution to ensure a user understands that an object is clickable is to transform the cursor into a finger cursor. And that's really important because you have your cube here. How can you tell to your users that this is clickable? Should you add like a 3D text with the arrow saying click there? It's maybe a bit too much. Maybe on its own it looks like a button, but you want to make sure that the user understands that he can click on it. And you're going to change the ideal solution on desktop is to change the cursor when we hover it, to change it to that, you know, that cursor that we see on links when you hover a links. I don't have a links right here, obviously, but it looks a bit like that. And you let the OS handle that. You just need to change to the cursor, the pointer cursor is it's the name. So obviously it's not working on mobile because on mobile we don't have a cursor. Makes sense. So on mobile, make sure that it looks like a button or something like that. Or maybe you have a quick tutorial that is playing. Maybe there is like a white dot and the dot is doing some impulse like that. Usually we understand that this is a clickable area. Anyway, don't worry, users on mobile tend to click everywhere. Okay, they just click everywhere to see what happened. So usually they found the links quite quickly. So we need to know when the when the mouse enters the cube like this, and when the mouse leaves the cube like that. When the mouse enters the cubes, we are going to change the cursor to a pointer, and when it leaves, we are going to change it to the default one. So let's go. To do that, we are going to focus on the cube again. I'm going to add some line breaks because it's getting a bit too long. I mean, that line is getting too long. So on click like that. We're going to listen to those events. It's going to be the pointer enter and the pointer leave. On pointer enter, and we send a function like that. Yep, on pointer leave, and we send a function to. And in there, we are going to change, you can do a quick test if you want, like we can do console.log like this. So enter, oops, enter and leave, just to make sure that we didn't do any mistake. And check that, I enter it, I leave it. Oh, I did a mistake, on pointer event. See, that's why we test. On pointer, enter. I wasn't focused, my bad. You probably saw it and were screaming at the video, stop Bruno. I know. So it's working, enter, leave, enter, leave, like that. But instead of doing those console log, we're going to change the cursor. And what I like to do, well, it depends on your application, but if all you have on your website is a WebGL experience, you can change it on the body at the top level. Or you can access, if you have other things on your application and you can scroll and get the rest of the website, maybe you should only apply it on the canvas, okay? Which is there on the canvas. And to get access to the canvas, we did it in one of the previous lessons. You can get it from use 3, the hook use 3. In there you get the GL, which is the WebGL renderer, and in there you get the canvas, which is the DOM element. So it's a bit long, but you can try on your own if you want. But in our case, all we have is WebGL in our page, so we're going to do it on the body. And to access the body, we can do document.body, and then we are going to change the style. This is native JavaScript. What I'm putting right here is native JavaScript. We're going to change the style and change the cursor. And as I told you earlier, there is the pointer, which will look like a link. The cursor will look like you're hovering a link, and the default, which will be the default pointer on the page. So cursor equal pointer, like that. And I'm going to do the same for the leave. In there, it's going to be default, like that. And check that, check my cursor. I hope it will work with the video. And it's becoming a pointer. And if I'm leaving, it's becoming a default cursor, just like that. And your users will understand that they can click on that. Nice, quite easy. But there is a helper for that. There is a use cursor helper. I'll let you discover this one because we are not going to use it, because I've checked it, I tested it. It's so simple. I mean, it's exactly what we did there. So that's one of the cases where we're not going to use a helper because, I mean, it wasn't even hard. So this time, let's not use a cursor. If you are curious, check the links. There is the use cursor. I mean, check the Dre repository for the use cursor helper. Nice. Next, let's try events. I spoke you a little about that. We are testing on a very simple object. Let's try with a more complex object. What happens when we click on a more complex object composed of multiple meshes? We're going to test on the classic hamburger. I really like that hamburger. It's already in the public folder. So if you check in there on the public folder, it's right here. And we're going to load it. Do you know what we're going to use to load it? Well, now it's the perfect opportunity again. Maybe you should try that yourself, okay? Pause the video and load the hamburger and add it to the scene. I don't know, maybe at the center, maybe a little above. Yeah, over there, right above at the center of the scene. Add the hamburger. Try that. And we are going to do it together. So we are going to use the use GLTF helper. So use GLTF from React 3 Dre. Then we're going to load the model. So it's going to be console. I'm going to, yeah, I can add it there. Hamburger equal use GLTF, and I'm going to pass use the path to the hamburger. As always, we don't put public folder, okay, because everything in the public folder is available like if it was on the same page, kind of, on the same folder of the page. So hamburger.glb. I'm giving it a reload. It seems to be working. And we're going to use a primitive, and we can add it, I think, at the end of the GSX. Yep. So primitive. I'm going to auto-close it, and I'm going to add some line breaks already because we're going to listen to some events and have more attributes. Object equal, you provide the scene. So it's going to be hamburger.scene, which is just a group. Actually, it's not a real scene, it's a group. And then we can scale it down because it's going to be too big. I can test just that. See, it's our hamburger, it's too big. We can scale it down with 0.25, which will be applied on the X Y, and Z. And then the position, so I didn't save, I can save. Okay, it looks like that. I'm going to move it up a little so that it doesn't collide with the other two objects. So 0.5 should be enough. And that's it. We have a hamburger. Nice. So easy. Since the primitive is a simple placeholder of the actual object, we can listen to events. All right, it's like listening to the group itself. It's like, don't do it, I'm just showing you something. When we're going to listen to events, we're going to do on, click, etc. It's like doing it on the group. So on this group, it's like writing on, click. And that's great. That means that we can listen to event directly on the primitive. So nothing to do, just put whatever you want to listen to. So I'm going to listen to the click event to start with. I think we're just going to use the click actually. And in there, I'm going to retrieve the event already. We're going to need this one because let's see what happened. There will be some weird things happening. And we're going to do, no, I don't want the loading manager, what the hell. Console.log click, like that. And what do we get? So it's working. Make sure that you have the exact same code as me. We're listening to the onClick event using the onClick. The click event using the onClick attributes, and we are sending a function. Okay, be careful. I added some line breaks. And let's test. I'm going to click at the center right here. See where is my cursor? I'm going to click there, and I got 4 clicks. What the hell is happening here? Let's try again. I'm going to click, I don't know, like on the bottom bun, and I got 1 click. And if I click on the meat, I get 2 clicks. And if I click on the cheese, I get 3 clicks. But if I click on the cheese on the side, like check there, I get 1 click. Do you understand what's happening? Every objects are triggering events. And I can do a quick drawing. You know, I like to draw, so I'm going to draw it. Ooh, let's try to draw a hamburger. So it's going to be, this is the top bun, or it's going to be ugly. This is the bottom bun, like this. And this is, it's so ugly. This is the meat, all right? And this is the cheese. All right, so bad. Anyway, you get the idea. When we are clicking on it, let's say the camera is above and we are clicking like that. So the camera is over there, like this. Tuk, tuk, tuk. We have multiple intersection points. There is one happening maybe over there, one happening maybe over there, one happening maybe over there, and finally one over there on each one of the meshes that compose our more complex object, which is actually just a group. Okay, the hamburger is just a group, and we have a bunch of meshes inside that group. That's the issue. So can we fix it? Do we need to fix it? Yeah, probably, because if you're doing, I don't know, you're making the burger jump or disappearing or whatever, some weird calculation and complex formulas, etc. You just want to do them once when the hamburger is being clicked once. Or if you are counting how many times the user clicks on the hamburger, I don't know what you're building, but let's say you want to count the clicks. You want to click to count only one. So can we do that? Yes, we can do that. Let me see. Oh yeah, by the way, we can test what object has been clicked on. I told you about that. If we try on the event, so make sure to add the event argument here and test on the object, what do we get? Check that. If I click just at the bottom here, we get this one here, and we have the name of the mesh, because in Blender, I've named those meshes. So it's the bottom bun, and we can test the name actually. Check that, name, bottom bun. Okay, I'm going to reload and click through everything like this, and we get top bun, cheese, meat, and bottom bun. And if I invert and click there, I'm going to reload the page again so that the console is empty. And now we get bottom bun, meat, top bun, cheese. Something weird happened with the cheese. I don't know why it's in this order. Maybe the origin of the cheese is wrong. Anyway, you see that some stuff gets reordered. Nice. We need to stop the propagation by calling the stop propagation method. It's exactly the same as we did right here. Okay, if we want to know just what element has been clicked. Oh, by the way, I told you that there is the object and there is another one. It's the event object. Maybe it's object event actually. No, it's event object. And see, that's the group, because we are listening When you test the event object, it's the one listening to the event, okay? The one on which we put the onClick, and for us it's the primitive, and the primitive it's just the group containing the hamburger. So if you want to know the name of the object, the top object on which you are listening to the event, you use event object. If you want to know the exact mesh that has triggered the event, you listen to the object only, okay? The object only, like that. And yeah, what we are going to do is simply test simply stop the propagation. So the first one, if it's this one, we just listen to the event and we stop the propagation, and those won't be triggered, all right? That easily. It will just stop, like this one won't trigger, this one won't trigger, this one won't trigger. And if we test, I don't know, in a different angle, like let's say from bottom to top, like this, the first one will trigger the stop propagation and the other one won't trigger the event. Just like that. With just one call of method, we can fix that small issue. So let's go. We are going to do it. Event stop propagation. I can keep the name like console.log event.object.name if you're curious to see which one will trigger it. And check that, I'm below it, I'm clicking, and it's going to be the bottom button only, because the bottom button stop the propagation and the other ones behind won't trigger the event. If I test from above, it's going to be the top button, and that's all, we fixed it. And we are kind of done with the lesson, kind of, because we have one more section to see. It's about performances. Listening to pointer events is quite a taxing task, especially for the CPU, alright? Most of the work is being done by the CPU, but it has become so easy, like with just one attribute, you put a function in there, you can listen to event. You might tend to add a bunch of listeners and forget about them. Just don't do it. Keep an eye on performances. Make sure to not do that too much, to listen to only events you really need to listen. Yeah, that's actually what I'm saying here. Avoid events that need to be tested on each frame. Those events right here, so on pointer over, on pointer enter, out, leave, and move, imply that there is a test on each frame. That it will be done by React3 Fiber. You don't have to do it, but internally React3 Fiber will do some tests on each frame, which is, it's quite a heavy task for the CPU, so you need to avoid those. That doesn't mean you can't use them, but if you can do without those, it's better. Also minimize the number of objects that listen to event and avoid testing complex geometries. All right, the click will be done on the geometry. If you have millions of triangles on the geometry, it will be really bad for the performances. When you click, let's say you're just listening to a click, and when you click on an object and you notice like the animation, there is a small freeze, like a little jump in the animation, you probably did some performances mistakes, and you need to work on that. And there is actually a solution, which is the mesh bounce. I really like this one. I discovered it really recently. It's a helper that will, instead of testing the geometry, like let's say we have this hamburger, there is millions of polygons in there, and the performances are getting bad when we click on it, when we hover it, etc. We have this solution, the mesh bounce. It will create a theoretical sphere. Like imagine there is a sphere around this, but it's purely theoretical. It's not an actual geometry, called bounding sphere. We used to call this kind of things bounding sphere. And the pointer events will be tested on that sphere instead. And for performances, it's much, much better. Like in there, imagine that instead of testing a very complex one, you test, I don't know, just a sphere. So the center will be calculated according to the object. It's going to test on a sphere like that. This means that the event might be triggered there, outside of the hamburger. But if you don't need a click to be very precise, which most of the case, we don't really care. It can be a bit around, like if you're testing that on units, test on Age of Empires, StarCraft, etc. If you click slightly, I don't know, like there on the units and not right here on the head of the unit, it will work. So you can totally use this in that case. It depends on what you're building, but sometimes it's better, and the performances are going to be so much better than you better do it. So let's go. Let's try to implement it to have a quick example. Yeah, also mesh bounce only works on single meshes. Okay, we can't use it on the hamburger. We won't be able to add it to the primitive hamburger. We are going to test it. Yeah, we're going to test it on the cube because well, a sphere. We won't see much of a difference. I mean, in performances, yes, but in the shape, we won't see a difference. But on this one, we will see a difference. You will see. So let's go. We're going to import it from Dre right here. So mesh bounce with an S. And then we're going to add it to the cube. So it's this one over there. And we're going to add it. Yeah, I'm going to add it after the ref attribute. And we need to use the raycast attribute because it's how the raycaster will be used on it. And we need to provide the mesh bounce, just like that. We didn't have to create it ourselves. We can just provide the helper and everything will be handled internally. So let's go, we can give it a try. See that? I'm going to hover it and see what's happening. The hover, it's like a sphere all around the cube, like that. So it's not as precise as before, but it's working perfectly. And if I click there, see? It's working. I'm a little outside of the cube, but it's working. If I go too far away, it's not working anymore. Canvas is telling me that I missed the click. But if I'm over there, it's working. On it, it's working. Over there, it's working. All right, nice. So use it if possible, and if you don't need such a precise click. Finally, let's talk about BVH. If you have a very complex geometry and you still need the pointer events to be accurate, you can also use the BVH, so it's bounding volume hierarchy. This one is not just about raycasting and clicks and things like that. It can also be used for physics, etc. But we are talking about clicks and pointer events, and you can use the BVH, so bounding volume hierarchy. It's a much more complex approach. All right, that's the reason why we won't even see it there. And I actually never had to use it. It's a bit overkill usually, but I think in the case of this lesson, it's when you have a very complex geometry and still need to know when the user clicks exactly on that geometry, you should use the BVH. And I have good news, there is a helper for that. All right, and I will let you discover it in case you need it. And we are done with the lessons. As you can see, it wasn't that complicated, and I will see you in the next lesson.